Good morning. Today we are going to discuss modeling and optimization. Now, just want to quickly talk about modeling and optimization. Modeling means that I'm going to use graphs or paper to make the model, and then the and optimization portion will be about looking at the model, the graph that you drew, and trying to figure out how to make it as big or as small as possible based on whatever question I'm asking you. Okay, so now 5.4 modeling and optimization, you will learn tricks of the trade to creating a model and optimizing that particular model. Um, so by the end of this little lesson, you will have seen one example, and you'll kind of have a strategy of how to organize and complete a optimization problem. Okay, so let's start off with the ideas or the strategies or the ways you want to do this. For step one, okay, anytime you're doing a modeling or any type of word problem, read the problem in its entirety. Read it all. You may even need to do it twice. Okay? So you have to read it, and then if there's anything you don't understand, look that up. Okay, now, next part two, you develop a model. So that's kind of like equations. Define it. Write an equation. Draw a picture. Okay, and then step three, you probably want to graph the function. Graph your model function. And then for your optimization portion, part four, after you graphed it, the part four is very simple. You need to take the derivative, find critical and endpoints, uh, and then lastly but not least, you solve and interpret. Okay, the biggest piece is at the top where you're doing the read it all. Okay, that's where you're really understanding it. And then at the bottom part, when you solve and get an answer, then you to your optimization, then you need to interpret it back into the real world or your situation. Okay, so now let's look at an example problem. Okay, an example problem, which the book likes to use, but I'll use, okay, two numbers. Uh, when you add, it is 21. And when the product is maximized. Okay, so I have two numbers. I've got number one and number two. Now, for first thing I'm doing is reading this, okay? I have two numbers that add to 21 and the product is maximized. Okay, so I want the biggest product possible of two numbers that add up to 21. So I have number one, My number 1, I'm going to define it as x. And my number 2, because I define my number 1 as x, my number 2, I'm going to define in terms of x. And I'm going to define it as 21 minus x. What you want to do is try to get as one variable as possible. So what you'll be working on is trying to work to get a single variable option. Sometimes it makes sense to make it 2 variables and then turn it into 1 variable. Like little stuff like that. Okay, so now I have number 1 and number 2. Now, my idea is that I have to take these two numbers, okay, because now this is the product. So P of x is equal to x times 21 minus x. Okay, which gives me P of x equals 21x minus x squared. Okay, now to find the critical points here, I need to take the derivative. So P prime is equal to 21 minus 2x. Excuse me. Okay, and then from here, from P prime, I set it equal to 0. 21 minus 2x. And then I get negative 21 equals negative 2x. And x equals 10.5. Okay, now that I get x equals 10.5, my two numbers that add to 21 and the product is maximized, I get a 10.5 times 10.5, and my value is my maximized value, which gives me